Yeah, it's been started. Okay. Anybody else? What are graphs?
Maybe a pictorial representation of equations on plane.
Does it need to be a plane only? Or plane as in how would you define plane?
I mean the four quadrants.
Four quadrants are plane. Okay. So you mean to say XY plane?
Yes,
Why can't there be a 3D plane?
yes, possible.
Then will it still remain four quadrants?
It will be 6, I guess, in that case.
Six quadrants. Interesting.
Yeah, 2, 6, 8.
4, 6, 8. How many? Well, 3 dimension has 8 quadrants, but that's not where we'll go.
Yes, 2 power 3, right? Yes.
Yes, 2 power 3. That's 8. So what we'll have is, yes, what you guys mentioned, it is correct. It is a pictorial representation, and also apart from it, it is also used to let you know where the points are located and how close or how far they are. So what all types of graphs do you know currently, guys, or you have idea of?
Bar
Bar
graph,
graphs.
line graph.
No, 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 not that graphs.
Okay, histogram.
No, no, no. Straight lines and all. Not bar graphs and everything. Those are all straight lines. I'm not looking that part. We are not going into data interpretation right now. We are still in quant. Like, if I have this as a coordinate axis, this is one of the graphs. Straight line. And straight line can be this, can be this, can be any type. What other types of graphs do you know, or other types of figures do you know? Anybody does it ring your bells? Something you might have studied in 11th, 12th. Just a rough idea.
Hyperbola, those things.
Those figures,
Parabola.
they come under geometry, I mean, coordinate. I'm not
Yes,
sure.
yes, they do, they do. So,
You're saying
what is a parabola?
The U-shaped thing, I mean, I think like
What?
x square is equal to, I mean, ax or something. I mean, y square is
Okay,
equal to ax.
okay, okay. That's the equation. Yes. Okay. Yeah, I won't go into that much deeper because it won't be required. But yes, that's how we draw the parabolas. Also, any other graphs?
Ellipse, and all. I mean, will they come under graph?
Yes, they do. They do.
Okay, ellipse, I don't know. I think x by a plus y by b something.
Trigonometric graphs. Anybody remembers when we studied trigonometry?
Sine forms, waveforms.
yes.
So we had seen the graphs of sine, cos, and tan. Remember?
Yeah.
Or it already went out of the mind. Temporary RAM में store करके टाटा. Okay. So yes, lines you can easily draw after the coordinate geometry session. The next part that we'll see is apart from it, and that's just the basic ones, not the advanced ones. What's a basic parabola? Basic ellipse. Hyperbola has two cases, the normal one and the squared one. So We'll see that part, and we'll see some more graphs which are actually functions, and this is where the next chapter coincides slightly with this chapter. So let's start it then. And this is this chapter is just for your idea, guys. This is not something you have to rote learn. You just need to have the idea. That is more than sufficient, because like I said, it will help you in easing out the calculations. So whenever we have the equation y squared is equal to anything, k into x, we won't go into 4x, that is not required. K into x, so y square is something into x. The general graph we have of parabola is like this. If we add something here, let's say if we add here 3, what we will have is, anybody any idea what we'll have?
The graph might move upwards, probably in the y direction. I mean, on
Yes, yes. When x is equal to 0, y square will be 3. That means you will have it on root 3 distance above. Why? Because y will be equal to plus minus root 3. It can be plus, it can be minus, that's different thing. So we will have the new graph like this. Here, root 3 distance above. If my bad, if this becomes a negative, this will come below. This is basically your normal shifting part. Same would go if it happens on the opposite side. And this is the standard procedure where you will follow across all the diagrams. This adding a constant or subtracting a constant. Just take one variable 0 and see how much change is there and accordingly place it. That's it. The structure remains the same. The shape remains the same. It's just that it gets shifted some units up or some units down. So this is your equation of parabola that will be required when y square is equal to kx. Which axis has the highest power? It's y. The graph will always be symmetric to that axis. Now let's take a new case. We can also have it like this: x square is equal to ky. Now it should be according to which axis now, guys?
X-axis.
Yes, and it will be like this. Now same here, if I add plus 3 or so, it will shift here or it will shift here depending on what are the signs and everything. If I put here minus, it will become like this. That's it, just the opposite one. So is this basic part clear, guys? Everyone? Okay, let's move forward. So with this done, we will have our ellipse. Ellipse ka common equation is x square by a square plus y square by b square is equal to 1. You don't need to remember the equation, it's just for knowledge. It's not asked or it won't be asked. If this is your ellipse, this is how your ellipse will be. This will be a, this will be minus a, This will be b, this will be minus b. This is known as the major axis. This is known as the minor axis. And this is pretty much all you have to learn. If I change this values, this ellipse will look like this, because we have assumed here a is greater than b. That's it, nothing else. Ellipses can have like this and like this shapes also, but for that the equation would be a lot complex and a lot different. This is the standard equation. This part is clear, guys? Anybody has any question? Yeah, one thing to know is when both a and b become the same, what will happen to the figure?
Circle.
Yes, it will be a circle, because circle has uniform radius throughout and ellipse doesn't. So if ellipse also has the same radius throughout, it will become a circle. This part clear, everyone? Okay. Let's move forward then. The parabola is done, ellipse is done. We will have our hyperbola, and in hyperbola we have two cases: the normal hyperbola, and we have one more, that's the special case. Normal hyperbolas are like this, and its equation is x square by a square minus y square by b square is equal to 1. This equation, just put a minus sign here and you will have a hyperbola. Hyperbolas are like this. The properties we don't require, this is just the basic fact, how it is drawn, how is it known, and everything. This is your normal hyperbola. Special one we will see right now. Special hyperbola you will have like this. Basically what has happened is, if I take this and rotate like till here, I say keep on rotating, it will become like this. But this a few minor difference as well. It's not the exact same rotation part, but you could consider it that it's almost like that. So this will be your graph of y is equal to 1 by x basically, or xy is equal to 1, or anything. Xy can be k as well, not an issue. The graph will almost still remain the same. Even the graphs of your x y raised to n is equal to k, or something on similar lines, or y into x raised to n is equal to k, the graphs will almost be quite similar, no changes. This is just for, yet again, you don't have to mug up it, you just have to have the idea. Especially graphs will not be used. Eccentricity, no. Credit, like I said, we are not studying here this in the coordinate geometry part. We are studying it only for understanding that how does a parabola look, how does an ellipse look. That's it. I do not want to know what is eccentricity, what is the major axis, minor axis. Minor axis and major axis I just told you for the basic knowledge. Eccentricity is then going too deep into quants, that is not required for CAT. Till here, is it clear for everyone? Any doubts? Any part that you did not understand? Is it clear, guys? Okay, great, then let's move forward. With that done, now we'll come to slightly we'll delve into the functions ka area. Functions can be of how many parts? Functions can be polynomials, you can have exponents, you can have log, and what else can be there, guys? And what else did you study? Anything else left out, or is it done? Trigonometry. You will also have some algebraic ones. Algebraic ones, I mean those which are different from polynomial ones, like your modulus x, your least integer, greatest integer, and everything. So the polynomials part is roughly covered, I would say, because let's say I give you the I'll take one thing. One important one is remaining. You had y is equal to ax plus b. The You can solve the graph. You have y is equal to x square, that will be a parabola that you can do. What if the graph is y is equal to x cube? The graph for y is equal to x cube is like this, not here. This will go here like this. Yeah, this is how it will go. Let me try it again. Yeah, this is generally how you will have your y is equal to x cube wala part. So whenever I give you any cubic equation, first of all, cubic equation should have how many roots? 3. Is the line intersecting 3 times? I mean, I have not drawn it accurately. It's somewhat like this here. If you have something like ax cube plus bx squared plus cx plus d, y is equal to, the graph you will have is something like this. 1, 2, 3. And this all threes are what I will call the roots of the equation. Or sometimes there's one more notation that can be followed, that is called the zeros of the equation, because when you put these values, the end result is 0. Till here it is clear, everyone? Anybody any doubt, ask me right now. Just don't ask me why the graph is like that, because when we construct it, it comes out to be like that. Okay, so if there's no confusion with that part, our polynomials is done. Let's see the exponents. This is your coordinate axis, and your exponential graphs are like this. This is 1, and then it keeps on shooting. So let's say your equation is this. Now if I put x is equal to 0, it will give me 1. X is equal to minus 1, this will be 0.1. If still minus negative something high number, it will be low, and it will at 1 it will become 10, drastically increasing. Instead of 10 you can have anything. And I will ask one thing, a raised to x and b raised to x, sorry, x is a positive number and a is greater than b. What sign will I put here? Option 1, option 2, or option 3? Type in the chat box. Let's see. I'm giving you guys 30 seconds. Yes, quite correct. The answers you have given me are this, and this is the correct answer. Great. It is quite easy. See, let's take a is equal to 5, b is equal to 2. If I take x is equal to 2, that would be, this number would be 1 by 25, and this would be 1 by 4. Naturally, 1 by 4 is bigger than 1 by 25, so this will be the answer. So yes, you are correct at that stage. Now, is this clear, everyone? How did we arrive? Anybody any doubt? Okay, okay, then great. Let's move forward. We are done with exponents. Let's see at the graph of a log. This is your coordinate axis, and one thing important I have to tell you is any opposite graphs that you have to draw will be a mirror image across this line. Y is equal to x is this line. This will be a mirror image. So your log graph will be like this. That means here it will be like this. I'm not quite accurate, but yeah. This is at the base A, what you are taking. Like if you have taken log to the base A something, this will be A. Because if you put here A, you will get 1. That's why. Or will it be something else? Anybody? Yeah, Pradeep, you was to say something?
Is the graph correct?
No, the graph is correct. What will be the value of this point? I'm asking. Log a to the power x. When will this be 0? At what value of x will this be 0? Because this is 0, right?
0. At x value 0, it will be 0.
X value 0.
Yes.
1.
No, 1.
It will be 1. Aswik, what is the value of this?
Log 1. Okay, I thought log 1 is 0.
Yeah, log 1 is 0.
Yes, so if x value is 0, then we'll get log 1, then the value will be equal to 0, right?
This is, I don't know if you could understand this part. This does not mean a raised to x. This means log to the base a and x, log of x it is.
Okay. What I
So,
thought was by default log base with 10 we take, right? So log
no,
of
no,
a
no,
power
no,
x.
no. That's why I'm specified here a.
Okay.
If nothing is mentioned, then we take the standard as 10. Otherwise, it's always log a. Standard procedure. So yes, this will be 1, and y is equal to x will be something like this. So your exponent graph would be something like this, the mirror image, where the mirror is the line y is equal to x. This was our log Trigonometry part we have already seen in the trigonometry section. Let's see how are the algebraic graphs drawn. In algebraic graphs, you have 2, 3 ones. We'll just see the basic, and that would be the greatest integer function. Now, what does greatest integer function do? Let's say you have 4.5. When you put it here, it returns 4. It always returns the number exactly, the integer which is exact, just smaller than this number, just smaller. So what will be the greatest integer of 5.5, guys? Minus 5.5 का greatest integer would be? Please type in the chat box. And I require an answer from everyone. I don't know how you come up with the answer. If I don't get an answer from you guys, I won't move to the next question. Two responses received till now. I'll tell you, Spandana, if it's correct or not. First, everybody give me your responses first. Others, we are 7 here, just 3 responses yet. Okay, now it's have increased. Those who haven't given me a response, 10 more seconds. Well, the answer would be unfortunately just 2 people have given me the correct answer. Like I said, guys, it returns the integer which is just smaller. Minus 5 is bigger than minus 5.5. In negative, the rules are reversed. Minus 5.5 is here, minus 5 is here, minus 6 is here. The number on the right side in a number scale is always bigger than the number on the left side. This is bigger. Here we have 5.5, here we have 5. This is bigger than this, but this minus 5.5 is bigger than this. So we'll have the just smaller number. Is this part clear, everyone? Okay, perfect. So with the greatest integer part, what we'll have is, let's draw its graphs then. So all the values till 0.9, from 0 to 0.9, what will the greatest integer value return? If I put it here, what will this return me?
The integer part.
Yeah, but what will be the value of that integer?
0.
Yes, it will be 0. So for all this will be it. This I'm including, this I'm excluding 1. If I put 1.1, what will this return me?
1,
And 1.99,
1.
1 again. So this is 1, this is 2. From 1 to 2, it will return me 1. So can I take this as the graph? Same will go from 2.1 to 2.9 something. Because at 2, my value would be 2. That's why this is a hollow circle here and this is a solid circle here. Something we had discussed in previous class. Same would go for the below ones. This function is also known as stepwise function or staircase function because it looks quite similar to a step. You climb like this. This is, I mean, sometimes the normal ways that they can confuse you: stepwise function, staircase function, greatest integer function, and so on. Is this part clear, guys? Everyone? Anybody any doubt? Okay, great. Then once we are done with this part, let's teach some more algebraic ones, the ones we did yesterday. Remember this? What was this function called?
Modulus.
Yes, modulus. So what happens is, let's say this is my graph. When I apply a modulus on this graph, what will happen is this portion till from here to here will vanish completely, and I will have a mirror image of it. All the things below x-axis will vanish and I will have a mirror image of that part. So the new graph would be like this when I put a modulus, and it can happen for anything or everything. Like let's say if I draw a parabola and now I put a modulus, what will happen is exact opposite. This will vanish. Everybody understood how the modulus works in graphs? Anybody any questions? Anyone?
Can you give one more example?
Sure, I will give it. So let's see how the log works. Or this is your 2 raised to x graph, the green one. How will its modulus look? How will the modulus look for this one? For the green one? This is the graph. I'm asking for the modulus graph of this. How will it look? Any idea?
Would become parabola.
No.
Then the same.
So you change your answers this instantly. What was the confusion earlier? How did it become a parabola? I just want to know.
Since it's not intersecting the x-axis at any point, so we cannot draw any mirror line, no.
Yes.
So then it would be the same.
Yes. Then how was it parabola before?
I was thinking about why it's cutting y-axis, so it can become parabola.
No. If it's mod x, you will only have to focus on mod x. That's it. We have something known as mod y also. There we consider y-axis. There what we did for x, and we do the exact similar thing for y. So guys, like discussed, the graph will remain the same because no part of the graph is below the x-axis. So it does not matter if you draw or No, sorry. If you draw this or this, the answer still remains the same because they are always positive. And on this basis, if I frame you a question that 2 raised to x minus 7 is equal to, no, plus 7 is equal to 0, find me the number of solutions of x. Can you solve it now? Or no, let's put it hit. Yeah. Can you find me the solution now? Answers in the chat box. I'm giving you 1 minute. And you have to represent your answer using same as usual, the brackets. See if you can give me the answer. Great. The value of x. I want just the value of x. It depends how you wish to give the answer. Totally up to you. Okay, interestingly, I've received just one answer. Others? I'm giving you 30 more seconds. 2 answers now. 30 more seconds, guys. I need the answer from everyone. Guys, what did I mention correct just now in the graph? Exponents never take up any negative value. So if I write it like this, am I not stating that this will take a negative value at some point of time? Is it possible?
Yes.
For what value? For what value is it possible?
3, I guess.
Sorry?
3, I guess.
So 2 raised to 3 is equal to 8. How did you get minus 8?
Yeah, we can write, I mean, how I reduced x value is 2x is equal to minus 8. So I've taken this thing, I've taken logs basically and did.
You do anything, you will still not get the value.
X minus 3.
Sorry?
X equal to minus 3.
Put x is equal to minus 3. What will you get?
We won't
Minus
get
8.
still. No, I even tried actually. I got 1 by 8 plus 8. That won't be 0.
2 raised to minus 3 is equal to 1 by... Guys, so if I put x is equal to 3 here, I will get 1 by 8, not minus 8. please understand, your any exponential value, this is your x-axis. There's no value below x-axis. That means no value will be negative. And next question I gave you is find me a value where this is negative, and I have received 3 answers. Did you guys understand it? How the exponential function works?
That means it's modulus always.
Yes, it is always modulus. That's what I said. Y is equal to 2 raised to x is equal to modulus of 2 raised to x. It's like telling the same thing. It will never return any negative value. Never. For any value you put. Y is equal to a raised to x exponential function. For any value of x, this will always and always be greater than 0. Always. This will never give a negative value. Never. So whenever you get some question where this is showing an equal to a negative value, the answer is no solution, because it cannot be satisfied. Is this part clear, everyone? Everybody? Okay. What I will do is, first I'm giving you 3 minutes. Revise everything, all the graphs and everything that we have seen today. 3 minutes. After that, I will give you some more questions and equations to solve. Take 3 minutes, revise whatever we have covered. If you have any doubt, you can ask me after 3 minutes. I'll solve everything. If you don't, it's great. Your fundas will be clear at least. Take 3 minutes, revise everything, guys, of whatever we have covered today. It's 5:26. I will ping you back at 5:29. Yeah, guys, so time's up. Anybody, any doubt? Or any questions they want to ask? Because we have learned the basics of graphs, we will now learn the basics of functions, and then we go to questions. We will solve the questions of graphs and functions simultaneously, as was the plan of action before. So anybody going forward, any doubts, any questions? It shouldn't happen that you, once you start learning functions, then you have some doubts on graphs. Okay, I see no questions, then let's move forward. So what are functions, guys? Anybody has any idea? Guys, am I audible?
Yes, yes.
Okay, then what are functions?
A relation between independent variable and variable dependent with some formula or equation.
Okay, quite correct, yes. Anybody else? Way to give their opinion as well. Okay. Well, yes, what you said is quite correct, and you will have it like for the relation between basically x and y. So putting some value of x, you get some value of y. Like let's say, whenever I put some value of x, I will get some value of y. We have also seen what will be the graph of this equation. Now let's find out how these things work. Here we have two things to remember. Here, this is the dependent variable. Why dependent? This value depends on this. If you change x, this will change. Generally, x is always considered the independent variable, because we start choosing any different value of x and we get some corresponding value of y. That's the reason. So coming back to our original one, and that was what is a domain and a range. So you could say all the values of x that are putting is domain, and all the values of y that you get in will be the range. Now I want you guys to let me know in brackets what will be the, how much can be the total range of values for domain, and what will be the total range of values for range. Do let me know in this equation. What all values can x take? Write it in this, and I want collective answer. What all values can y take? Minimum value, maximum value, everything. I'm giving you guys 2 minutes. Think. I hope the domain and range part is clear. Anybody has any doubt with domain and range part? Okay, no problem. Then take 2 minutes and give me the answer. Asvik and Manideep, who supplied the values to whom?
Actually, mistakenly I sent to Asvik Kesari. Below you, it was Asvik, so mistakenly I sent to him.
Okay, all right. And the domain, okay, the range, okay. Yes, perfectly. You guys have quite given me the correct answer. The domain has to be from -2 to infinity because y square will always give me a positive value. That means this RHS should always be a positive value. When it can be a positive value or a non-negative value, because this cannot be non-negative, it can be 0. I had a discussion with Aditya yesterday in the class of 0 is negative, non-negative. So yes, I would stay to that one. This should not be non-negative. It can be 0. So x can take at minimum -2, and then it can take any value till infinity. That's not an issue. This is the domain part covered, and this will be the including bracket. Now covering the range. This LHS, whatever that be, for x is equal to -2, this will be 0. So its corresponding value will be 0 here, and so on till infinity. Now, what we will have here is no negative values because it's y square. Since no negative values will only stick to one side of the equation, so yes, what you guys have said is quite correct. The range and the domain. Others who haven't answered, have you guys understood it? Please type in the chat box if you have.
No, Kesari, I didn't understand.
Okay, I will explain it. Others?
It's clear, Kesari.
Those who haven't answered the question, have you guys understood it or not? Please let me know, guys. This is a very important concept going forward. Very important.
Not really, Casey. I didn't get it.
Okay. I'll explain it once again. This will be what is the graph. Is this part clear, guys?
Yes, Kesari.
Now we will let go of this part. We will only have this much. Why we should let go of the other part?
Y square is always positive.
No. Yes, sorry. Y square is always positive. Yes. Guys, one thing I need to tell you, and I think yes, that is correct. Coming to the x part and the y part, there's a, how would I say? Yes. So coming to the domain and the range part. Domain means all the values of x. Like there are two things, and these two I would say are your definitions. So the definition of a domain means all the values that you can put in x. The range means all the values that you can put in y. Is this part clear from the previous statement, everyone?
Yes.
Anybody, any doubt, please ask me right now. Anybody? Okay. Guys, there's one thing I need to tell you, and I made a mistake as well quite here. Where was it? Here. The thing is, no, this is correct. Yeah. The graph of y is equal to kx square is like this, and this is the graph of y square is equal to kx. I made a small mistake. I realized it just right now while I was explaining it. So the axis which has the degree 1 is where this will be symmetric. Here the degree of x is 1, hence it will be symmetric across 1. Here it is the degree of y is 1, hence it will be symmetric across y. Please make that correction. I just realized it now. I taught the just the reverse, so my bad for that. I hope that part becomes clear. Is this part understood? What change has to be made? This is this, and this is this. Y square is equal to kx. K can be any value. If it is mostly positive, it will be like this, negative like this. This is y square is equal to kx ka graph, and y is equal to kx square ka graph. K is positive. This will be the graph. So now coming back to the question, y square is equal to x plus 2. This is how the graph would be. Y value will never be negative. X can be negative and positive as well. X can be negative and positive as well. But there's a twist. If you start putting negative values here, what you will get is y square taking negative values. Let's say if I put x is equal to, sorry, minus 7. Now x is equal to minus 7. Does it lie on this side of the axis? Anyone? Will I find x is equal to minus 7 here?
No.
It will be present here. That means I cannot take value less than 2 here. Sorry, y square is 2, no? Yes. Did I miss a thing? No, it's correct. Let me draw it clearly.
Basically, it would be minus 2.
Sorry?
It would be minus 2.
Minus 2 4.
Like the parabola should come.
It should cut here, right?
Yes, it should cut
Yeah,
here.
yeah. That's why I'm drawing it again. So when your x will be minus 2, your y value will be 0. and we will have this part. Now you can see here, when we put x is equal to -2 plus 2, your y will be 0. Y is equal to 0 means x-axis. From here -2 you will have -1, 0 and so on. You can put all the values and the function would grow, the graph would grow. So coming to my original statement of what's a domain and what's the range. All the values of x are known as domain. All the values of y that can be fitted here is known as the range. Can here y have negative numbers, guys? Can this part be possible? Anyone?
No, Casey.
Why?
Otherwise, it would be imaginary.
Yes, it would be imaginary. Quite correct. Guys, like I said, if I place here and if x ka value is anything like x can be, Prerit, how come imaginary?
If x is less than -2.
So what? Let me give you an example.
Root.
If x is equal to 2, okay, x is equal to 2. So my RHS ka value would be 4,
Yes.
correct? Now why can't I have y is equal to -2?
So suppose if x is equal to -4.
So that is not there in the graph itself.
Okay.
That part I got it. That is not there in the graph. That's the difference why I took up graphs initially. Unfortunately, I explained the wrong part as to how a parabola is drawn. Now which I'm telling, this is the correct one.
So we have to put the minimum value of x. So to get the minimum value of y.
Yes. So minimum value of y is 0. Is that what you're telling? Okay, I'll tell you. Always it won't happen that when you put minimum value of x, it will return the minimum value of y also. This is not the case every time. Sometimes, and in some equations, it has to be framed like that. When you put minimum value of x, you will get the maximum value of y.
Like reciprocal.
Yes? So it all depends on the equation as to how much the range and domain are affected by the minimum and maximum value. So coming back to the question, the domain and the range, the domain would be all the values of x. Here I can put only from -2 as the graph suggests, only from -2 to infinity. I cannot have these values because they are not in the graph. So it will be -2 to infinity. But the range that you guys mentioned, that won't be the case. The range would be -infinity to infinity.
Yeah, got it. because x will tend to always to infinity, no? So y can take
Any value.
any value.
Is this part clear, guys? Everyone? If I just restrict it of what you are telling, see. If I restrict it, how I say, of only this, like if I say this part is not present, I'll try to not complicate it. It's slightly out of our topic, but if you understand this part, this will help. What we drew here is the domain and the range. Quite correct. And initially what you had stated, this one. This is then, this is this. Yes. This is correct. There's something called as functions and relations. I know we are studying the functions part, but if we have the proper set diagram, this is relations, and inside that a small part is functions. Completely, it's actually relations. So when we are seeing the function part, what you guys gave the answer is initially correct, because there's a difference of what the function and relation has. Will not go into it. What the relation will have is infinity minus infinity to infinity. So if I ask, and since the syllabus for you guys is functions, let's keep it that way, I guess. The answer, let's keep it 0 to infinity. Let's not go into relations for now. If we go deep into functions and relations, it might complicate it. Let's keep it simple then. So yes, whatever you guys stated, range and domain initially, Uttam, Ashvik, and Prerit, yes, it's correct. And even Manidip had stated it, yes. Prerit, is your doubt cleared now? What's domain and what's range? Just in a nutshell, if I have to say, the domain is the values of x, and the range is after putting all those values, whatever value you can get, that's the value of your range.
Yes, Kesari, clear.
Others, I guess somebody else, or even Janvi had a doubt. Has she left? Yes, I think she is not there. Okay. Okay. Functions, let's move forward then to the next part. So functions, you will have various things. Some on I just wanted to ask one thing. Janvi, you're connected now. Did you just miss the last part?
Yes, Casey, I was just about to ask you the same.
Okay, yeah. So I just wanted to say in a nutshell that domain is all the values that x can take. And x is allowed to take. And when you put all those values here, you will get some resultant values. Like if x plus 2 is there, if I put x is 0, the net value of this will be 2. If I put x is something, the net value will be something. Collection of all these values would be range for any given function. Now is it clear?
Yes, Casey, it's clear.
Okay. If see guys, this functions and relations part would be too much of a calculus part, and if I try to explain each and everything deeper and deeper, it might create a lot of confusion. So let's not go into relations part for now. Let's just stick to functions. Anybody who has idea of what are sets? Just the basic idea.
Collection of distinct quantities.
Okay, yes. Anybody else? Anything to add? You guys might have studied it in your till 10th standard, right? Or it wasn't there?
CBSE.
Okay. So then it was there in your 11th standard.
Yeah, it was there, but with less of grip on.
Acha. Okay. Okay. So yes, basically what was said is quite correct, I would say. It's the collection of various distinct objects, I would say. And those objects can be anything. It can be numbers. It can be different entities, collectible entities, non-collectible entities, anything. So the basic operations that you will have union, you will have intersection, and you will have set ka complement. Are these three parts clear to you guys, or you want me to explain it just in short first?
It's clear to me, Krishna.
Sorry, I could not hear you.
It's clear to me.
Okay, others?
The complement part, is it just the negation of the existing?
Yes, it's just the negation of the set. Anybody who wants me to explain this concepts, please tell me right now. Okay, I see that it's clear. Then let's not move to that part. Anybody knows what's our disjoint sets? Okay, if the intersection of two sets is basically they do not have anything in common, nothing is in common, intersection is nil, they are known as disjoint sets. Now did you guys understand what are disjoint sets? Okay, next would be the difference. So let's take two sets A and B. So what would be the difference between the sets? That would mean something that is present in A but is not present in B. So let's say there's this A and there's this B. So A minus B would represent this part, all this part. Is this part clear, guys? Everyone? Till disjoint and difference of sets. Anybody has any doubt? Ask me right now. Okay. So with that part done, and the basics, there was one law, one popular law in sets. Anybody remembers the name?
De Morgan's.
Yes, De Morgan's law. There were two laws, actually, basically the same version of each other. So the laws were A into B ka complement is equal to A complement intersection B complement, and the other one was same but just the reverse. This the proofs won't be asked, that was 11-12 standard stuff basically. You just have to know and remember them. That's it. And coming to one of the final things in functions would be Cartesian product. Let's say set A has 2 elements, set B has 3 elements. So if I do the operation A into B, the Cartesian product, it would be 1 into 1, 1 will go with 1, then 1 will go with 2, this one will go with 2, then this 1 will go with this 3, and so on. Next 2 will go with 1, 2 will go with 2, and 2 will go with 3. This is the Cartesian product. So the number of elements in a Cartesian product is this into this. This is how we obtain a Cartesian product. Is this part clear, guys? Everyone? Anybody any doubt with this part? Okay, perfect. So with this part done, let's solve some questions. Uh, let me know what is this, what is this, what is this, and what is this in the chat box. I am giving you 2 minutes. Yes, I guess you guys have given the answers quite correct. Great. I see then these concepts are cleared. Now what we'll do is, guys, the basic concepts I would say is complete for your graphs part and your functions part. There are 1-2 advanced concepts. We'll keep that 1-2 advanced concepts on a hold for now, just for now. We'll come back to it later. What we'll do is right now is we'll take up some problems, and that would require the combined knowledge of your graphs as well as your knowledge of functions and the sets that you have been taught. So we'll do that part, and then we'll move to the series and progressions wala part, the small conceptual part. It's not that big, but I want to have a break between those three parts combined so that it does not create an overload for you guys just for the day. So the questions here they are. Mhm. This I would say is a moderate to difficult level question, not an easy question. If you cannot draw graphs, trust me, it is a very difficult question. If you can understand graphs comparatively, it's a moderate question. How many solutions will you have? I'm giving you guys 3 minutes. You draw graphs, you put values, whatever. If you can draw graphs, that would be really easier. You can solve it in 30 seconds. Otherwise, it will take 3 minutes. I'm giving you 3 minutes, so don't worry. No, Uttam, the answer you have given is not correct. Uttam, I didn't ask for the interval value. I just wanted the number of solutions. That's it. Prerit, no, your answer is not correct. Ashvik, yeah, it is correct. Yes, now Prerit, it is correct. Others, I'm waiting for your answers. The 3 minutes aren't up yet, so you still got 1 more minute. No, Manideep, not one value. We will have more than one. Okay, time's up then. Others who couldn't give me the answer, where did you guys get stuck? Like Janvi hasn't given me an answer. Janvi, where did you get stuck?
I really don't actually. I'm just stuck. I'm still stuck with graphs.
Okay. Spandana, I haven't received your answer as well.
Yeah, same thing. I tried drawing the graph. I got 1 point of intersection, like say a power x, I mean 2 power x plus 5.
Okay.
So I shift the unit by 5.
Okay, sure then. I'll see. Guys, you can directly cancel 5 and 5, right? I purposely gave you 5 and 5. If I had given you 1, 5 and 1 some other number, the question might have become slightly difficult, slightly, not much. Otherwise, it's still the same. If this is your coordinate axis, your 2 raised to x will be something like this, where this is which point, guys?
2.
1.
2 or 1. At x is equal to 0, this will be 1. 2 raised to x, put x is 0, you will have 1. See guys, mastering graphs is not easy, I understand, and that there's a reason why I am not going to the advanced part of functions today, because if you guys can revise this graphs wala part, we'll discuss this advanced part of functions after 1 or 2 days, so that the small points and all are cleared with everyone, and when I go forward I don't face any issues. So whenever you have such boundary conditions, put the values and you automatically get your answers. So this will be 1. Now let's draw x square ka graph. X square is something like this, right? Now you will tell me how to determine this one. Well, this won't be accurately like this. Let me tell you how this will go is, this will be like this, and this will go till here or here or here. This part is an equation one. Let me graph it. uh, do I have the option? One second, let me minimize the chat window. Hold on guys. Okay, I was trying to get the graph. One second, hold on. Mm, no, this is not it. Just give me a minute guys. This is your 2 raised to x, and for x square, let's graph it. Okay, so it does not show individually. Then let's plot it here itself. Guys, is the screen visible?
Yes, Keshu.
So guys, can you see the graph on the right side?
Yes,
How many solutions can you see?
3.
3. And let me show you the graph as well. And I will tell you why or how to change or determine something. Like you might have seen, 2x ka graph drastically moves upwards. Okay, but there's a some point. And what point? Till x is equal to 0, this is 1. At x is equal to 1, this is 2. At x is 2, this is 4, right? And it gradually moves till 3, it will move till 8. Now this part is clearly known. We have one point of intersection here. But what will happen with x square? Let's see. At x is equal to 1, this x square wala part will be here. At x is equal to 2, it will meet, right? X square.
Yes.
Now what will happen is, this grows slowly and this grows rapidly. This is somewhere the third point of intersection would be. And that is why this equation is getting 3 roots, as you can see. It is, one is at this, one is at this, and one is at x is roughly near 4. So it will be roughly there. You need to have an accurate graph, so you will get somewhere around here. At x is equal to 4 and y somewhere here. X is 4, y is 0.04, somewhere. This is where you will having something like this helps in your part. Unfortunately, this is not available in your cat, but it does, the OneNote feature. Hopefully I won't be advertising OneNote. So for what we are here is now coming to the part, how will you come to determine this part? Because this is where I guess all you guys must have confused, right? This part was pretty clear, one solution. Even this part could have been clear, two solutions. Will it have a third part or not is how to determine it. Guys, I just want to know how many of you guys have studied calculus? I just want if you guys know differentiation or not. Don't worry, I won't be teaching it or I won't be asking. Do you know or do you have you guys studied differentiation? Everyone?
Yes, kids.
Yes, Casey.
Anybody who has not studied differentiation? Okay, great, perfect then. What is the differentiation of 2 raised to x?
Same 2 power x.
Uh, it will be the same. And you can have a log a, but that's not important. It will still be the same. What will be the differentiation of x square with respect to x?
2x.
Yes, 2x. Which one is bigger? This is bigger or this is bigger?
2 power x is bigger.
2 power x is bigger. That means the slope of this graph, because differentiation gives you the slope. The slope of this graph will increase drastically compared to this one, right?
Yes.
Now, let's zoom into this part. At this point, y is equal to x square overtakes it, right? At x is equal to 2. This is your y is equal to x square and this is your 2 raised to x. If this is growing at a faster rate than this green one, will it somewhere or the other, I don't know where it will, it can be at any other point, but will this red line overtake this green line at some point or the other?
Yes.
Anybody who did not understand this part, please tell me. I will explain it once again.
Will you please repeat it again?
Yeah, sure. Okay. Let me put it in easier language first. Then okay. So let's say this is 5 kilometers. You are walking on foot and there's a car behind. 5 kilometers. And this car is at 100 kilometer per hour and you are walking at say 2 kilometer per hour, normal. At some point or the other, will this car overtake you?
Yes.
Okay. Same thing is happening here. This red is the car, this green is you walking. You initially have a head start here, but gradually will the car overtake you somewhere?
Yes.
So when the car will overtake you, will it also meet you somewhere?
Yes.
And it has already met in 1 and 2 points already.
Yes.
So there will be a third point, right?
Yeah.
That's it.
Oh.
Now guys, tell me, if I do not use graphs, how will you solve this question? If I don't use graphs? I know you might not be feeling graphs very easy right now, but that is because it requires a few days of practice to get acquainted with the graphs. If you guys want it, and this is just for extra work, I mean it's not compulsory also, there's a book that comes. I mean, this was one of my favorite books while preparing for my 11th and 12th standard. You can download the PDF. If I find it, I will share it. Otherwise, if someone of you finds it on the internet, please share it in the group. You do not have to learn from it. Trust me, you do not have to learn from it. Just have a glance. That is more than sufficient to understand how to solve and what to solve this type of questions. You are just finding it difficult slightly right now. It is because you are just not acquainted with the graphs. Now let me know, if I do not use graphs, how will you guys solve this question? What method will you use? I just want to know. I'm not asking you how what will be your answers. I am asking you, how will you approach this question then? You do not understand graphs. You do not know graphs.
Maybe we have to do a lot of trial and error or use
Yeah.
logs.
Applying log.
How will you use log here?
Yeah, because we can't find out log x value. We don't know x.
Yes. Prerit, you were telling something?
No.
Okay. Then any other possible solution apart from hit and trial? Yes. As Ashvik had said, we will have to use hit and trial. We'll have to start putting values of x and compare both the sides if we do not use graphs. This is where graphs comes in a lot handier. Once we reach to the advanced concepts, trust me, you will actually understand the true power of how efficient and important graphs should be. Is this part clear, guys? Everyone? Anybody any doubt as to how we solve this question now? How we had three solutions? Okay. So for today, we'll stop the functions and our graphs wala part. Like I said, the basic concepts, everything has been known to you. There's just one or two advanced concepts. It will not take more than half an hour. But the important thing is you should get acquainted with the graphs. So I will give you a few days of rest for this graphs wala part, and we'll come back to that half an hour wala portion in just before we complete our quant part. That is like 2-3 days away. Our quant is more or less complete. We'll be starting with then the DI wala part. So the important and the last part for today, and that would be sequences and series. I would say the easiest chapter of algebra, the easiest one. So 10th standard, everybody remembers what is your arithmetic progressions?
Yes.
Okay, Prerit already had the book. Prerit, did you find it, or did you had it?
I found it.
Okay. And where did you find it?
Google.
Oh, the great Google Baba. Okay. So what was your arithmetic progressions, guys? Anyone? In arithmetic progressions, we had the starting term and a common difference. So if you start adding the common difference to the sequence of the numbers, they will follow a pattern which was known as arithmetic progression. Similarly, in geometric progression, we had an initial starting number and you keep on multiplying by r, the subsequent numbers. The numbers would be ar square and so on, ar raised to n gradually. This sequence was known as geometric progression. Now then we had various formulas of how to find sum, how to then find apart from sum, the arithmetic mean, geometric mean. Anybody remembers how to find the sum of this? This sum is quite easy.
A
How
by
to find?
minus r.
Sorry,
A by 1 minus r.
that is the
For
infinity infinite ka sum. How do we find the standard one?
That I don't know.
Okay, let's learn that first. AP is quite easy, GP is hard. So this is the sequence AR square, AR cube, and so on till AR raised to n. What I will do is I will multiply this whole term with R and write it below. I am writing this term here, this term here. Now what I will do is I'll subtract this completely. So this all will become minus, this all cancelled, this is remaining. So I will take 1 minus r as common, sorry, r minus 1 as common is equal to a r raised to n plus 1 minus a. So the sum is a common r raised to n plus 1 minus 1 divided by r minus 1. Did you guys understand how we got the formula of the sequences and series ka geometric wala part? Anybody who did not understand? Aswi, did you understand it?
Yeah.
Janvi?
Yes, yes.
Manideep?
Yes, Kesri.
Okay. Prerit?
Yes.
Okay. Spandana?
Yeah, Kesari.
Okay. So this is basically the most difficult part. The arithmetic progression is quite easy and you guys already know the formula for it. What is the sum for arithmetic progressions, guys? This is the sum of an arithmetic progression where a is the first term, n is the number of terms, d is the common difference. Apart from it, there's nothing in this chapter that will trouble you if you guys understand this formula and this concept. There's harmonic progression, there's harmonic mean. It is neither asked hardly, and if you guys master this, the reverse terms are, what is harmonic progression? It's arithmetic progression using reverse terms, reciprocals. So anything you require in an HP, be comfortable with arithmetic progression. That would be more than sufficient, more than enough for you. So let me start with a sample basic question. of how the progressions would go. Where is it? Yeah. Okay. So let the question be then, three terms in an AP, arithmetic progression. The sum is 45. Difference, sorry, not difference, product is 3240. You have to find those three terms. I'm giving you 3 minutes. Let's see. I hope everybody has understood the question. There are three terms. They are present in arithmetic progression. The sum is 45 and the difference is 3240. Please identify the terms.
Product or difference?
My bad. I keep telling it difference. The product. Yes, Prerit, correct. Yes, Manideep, correct answer. I'm waiting, guys. One more minute. Ashvik, is the product 45? Sorry, sum is no, but the answer is not correct. The product is not 3240. Please check once again. Correct answer, Spandana. Okay, so let me start then. Guys, whenever you are faced with such a scenario where you guys are given the three terms, always make it a habit of using this template. Did you guys use this one in this way? If you
Yes.
use it, great. If you haven't, please use this, because the sum will always be 3a. That means a will become 15, and this will be your remaining terms. Now 15, this is x1, this is x2. Okay, so 15 into x1 into x2 is equal to 3240. Let's divide. 15 twos are 30, 24, 15 ones are 15, and 15 6 is 90. 216 is basically your a minus d into a plus d, where a is 15. So 15 square minus d square is equal to 216. 225 minus d square is 216. D is equal to 3. So you have 12, 15 and 18. Simple as that. Asvik, you used more of a guesswork, right?
No, 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 not guess. Actually, I got the value 15, but the mistake which I did was I assumed the sum to be as the arithmetic mean.
You assumed the sum to be higher. I did not get
I
you.
mean, I've understood the wrong question wrongly.
Okay.
You have given the sum, but I took it as an arithmetic mean, and I kept that formula and I tried that way.
Okay. But if the arithmetic mean is 45, then how come your numbers are 10, 15, and 20? Then the arithmetic mean comes here 15, not 45.
Correct.
Okay. So guys, did you understand now how you will have in this one? And one more thing. Whenever you are faced with a geometric mean, what is the template that you will follow? Geometric progression. 3 terms are in geometric progression. What is the template that you will follow? Let's say I given 3 terms. Product is,
A by R, A R.
yes, perfectly. A by R, A R. Why? When you multiply, this gets cancelled, you will have A cube. So let's say I've given the product is 216. You can easily get A is equal to 6. I hope this part is understood by everyone. This is a template you have to follow. There's no hard and fast rule that you guys need to follow it. It's just that if you follow it, you will get the answer much quicker. That is the only thing. Okay, let's move to an easy question of geometric progression. So 17th term and 28th term of an arithmetic progression are 66 and 110 respectively. Okay, this is 17th, this is 28th term. I want to find the 33rd term. The general term of an AP, A into n minus 1 D. This is the nth term. If you want a hint, I wish to find the 33rd term. Please find it. This will be our second last question. We'll have one more last question to wrap up before. Manideep correct, Prerit wrong, Ashvik correct. Prerit, we have found the 34th term, not the 33rd. The answer is, guys, 130. How we can do it? Plain and simple. Standard formula method is 66 and a plus 2070 because it was 28, right? Yes, 28 it is. So that was 110. When you subtract it, you will get what? 11d is 44. So d will be 4. When you put here d will be 4, 16 4s are 64, a will be 2. Now put this in this equation and find the 33rd term. For that it will be a plus 32 into d. That will be 130. Is it clear, everyone? I haven't received the answers from half of you. Spandana, no answer. Janvi, no answer. Have you both understood this part?
Yeah, okay.
Okay. Let's move to the final question of the day, and then we'll wrap up. For the arithmetic, geometric, basically, what we'll have is we'll have one more session of this one. Like we discovered all the basics today of graphs, functions, as well as sequences. The next session we will have is on, that would be on Tuesday. Yes, on Tuesday we'll have initial 1 hour for the advanced part, and we'll have 2 hour session on that day. And next 1 hour that we'll have is the topic that was to be covered initially. So I would request you guys to just revise this one again. AP and GP won't be required, but graphs and the function part, yes, please do revise it. I mean, do you guys have your first important thing? Do just have a quick glance of the book, the Play with Graphs that is being uploaded. You do not have to memorize it. Just have a quick glance is more than sufficient. Or else I will mention the page numbers tomorrow. You just, before coming to the lecture, just have a quick glance over those pages. That would be more than sufficient to handle the graphs. And what it will help you is understanding the functions. Like I said, when I drew the graph using that grapher tool, it made the question much more understandable and clear picture. That is what graphs provide. So we'll be doing that part. Anyway, today's final question, and that is, I have 3 numbers in an arithmetic progression. 3 numbers in an arithmetic progression whose sum is 24 and sum of squares is 200. Find the 3 numbers. 2 minutes, as this is very easy question. The sum of 3 numbers is 24 and the sum of squares of individual squares of those 3 numbers is 200. Find the numbers. Yes, Panditip, correct. Yes, Janvi, correct. Others, hurry up. It's a very easy question. 30 more seconds, I'll take it up then. Ashwik, I don't understand. By correct, you mean?
I have sent you the answers, right?
One second, I could not see it. Yeah, sorry, the answer got lost. Yes, yes. Yes, Pandana, the correct answer, yes. So it is 6, 8, and 10. I see everyone has got it. So great. You have to take a minus d, a and a plus d. You will get a as 8. Then put 8 minus d ka whole square, then 8 square, then 8 plus d ka whole square. You will solve it. You will get the value of d as 2 and minus 2. Which one should you take?
2,
Why not minus 2?
because you have considered the AP as A minus D.
What is the problem?
But the sequence would become incorrect, no?
I never said a minus d is smaller than a.
Then we can take both.
I said a minus d, a and a plus d are an arithmetic progression. I never said a minus d needs to be smaller. It can be bigger. You can have an arithmetic progression where d can be negative. So let's take the starting term is 14. It can be 13, 12, 11, 10, 9, and so on. One will start reducing every time. It will still be an arithmetic progression. Arithmetic progression did not have an increasing difference. It can also be reducing. It can, the d can be negative. Same goes for r. Let's see as the first term as 100. I take r is equal to half. The next term will be 50. Next will be 25. Next will be 12.5. Next will be 6.25. You can always have one. There's no such restrictions on d and r. Is that clear, guys? Everyone?
Yes.
Yes, Kesari.
Okay, perfect. So then we'll end for today and we'll continue the next time. I would just advise you to revise the graphs and the functions part carefully.
Kesari,
Yes, go ahead.
when you will share the graph worksheet, so we can at least start solving, because
Graph ka there is no as such worksheet, like I said. Algebra worksheet, yes, I'm preparing it. Like I said, once all the algebra topics get covered, and the algebra topic is quite large, like from the previous week, whatever we are doing basically is all algebra, and that will have a combined worksheet. So that is almost done.
so what today, what all topics we have studied, so
Haha.
these all topics worksheet is combined then.
Yes, it is combined.
Okay, so when you share that.
This you will get in 3-4 days.
Okay.
When this all topics of algebra will be done with.
Okay.
What I can also give you is, like I was mentioning in the last lecture, one workbook, and I can mark you the questions so that you can get some standard practice questions, because the questions that I will be giving in the worksheets will be tough. They won't be easy. Like you'll have to solve for 3-4 minutes each question. But I can give you one thing that I can give you tomorrow. That is, I'll give you a workbook from where I can just mark the questions and you can solve it as some practice questions. It will also have some easy questions for you to solve.
Yes, that would be great.
Okay, I'll do that part, sure. Others, any doubt?
No, Kesari, clear.
Okay, then we'll wrap up for today.
Thank you, Kesari.